Hello! In this video, we're going to be talking about function notation and how we use that function notation from a graph or based on an equation. So if we are given a graph and we want to figure out what f of -1 is, mouse trying to bite me, we want to think about when x equals -1, what is our y value for that thing? So we kind of go over here to -1 and we say, hey, that's the point 1, 3. So that makes f of -1 to be 3. If we want to do f of 0, that's the point right here. When the x value is 0, the y value is 2. So f of 0 is 2. If we wanted to do f of 1, that is saying, okay, well, when we are x is 1, where is our graph? Now remember, if we have an open circle, that means we just approach that thing. So there's nothing actually there. Same thing with this point. We just approach that point, but we don't actually reach it. And because we approach both of these points but never actually reach them, there's nothing there. 1 is not part of the domain of this function. So f of 1 is undefined. If we looked at this example, h of 0 is where the x value is 0. So that's our point up there. It doesn't really have a dot, but it is still part of our function. So that would be our y value of 4. H of 4 is when our x value is 4. We've got 3 points there. So we've got that open circle, we've got this filled in circle, and we've got another open circle. But h of 4 is just going to be that filled in one. We don't care about these two open circles because that's just where the graph is approaching, not where it actually is. So h of 4 is going to be 0 because we want the y value of this coordinate point. If we wanted h of 6, that's when x is 6. And so then we get the y value down there, which is going to be -1. If we see a question that looks like this, where it's the values of x that correspond to f of x equaling 2, that's asking about like, hey, what x values can you put in that we get out a 2? Well, hey, we already got one. F of 0 was 2. So the answer to this question starts with x being 0. Because if we put a 0 into there, we get that y value of 2. But there's more. We want to kind of like puddle around on here and say, okay, when else is it 2? Right here, we get a y value of 2. What's this thing's x value? Oh, it's down here at 3. So the two x values when f of x equals 2 is 0 and 3. We can put 0 and 3 into this function and we get out 2. In this example, the values of x that correspond to f of -1, I had a 1 there, but 1 isn't very exciting. When we check 1, we kind of look around and it's like, oh, there's nothing there. So it would be nothing. But we get something interesting when we look at f of x equaling -1. We got one earlier. H of 6 was -1. So that's one of our values. That would work. But hey, 7 would work too, and 8 would work, and 5 would work, and like a half, and like it's all of these values. There's a lot of them, and I don't want to list them all out. So instead, let's do an interval notation. That interval notation would start with a parentheses here at 4 because we don't want 4. That's got an output of 0, so we don't want that. But we want to get really, really close to 4, and that's what a parentheses is going to tell us. And we want to go to infinity because this is a nice horizontal line. It'll keep going towards positive infinity. So 4 to infinity are all of those values. I chose to use interval notation here because otherwise there's an infinite number of things to list out, and I just don't have the time to list them out. So I use interval notation and it's done. An important thing to note about interval notation when looking at an equation is saying that, hey, it is not a multiplication operation. So this g of t minus 2 is not going to be the same as like we could distribute the g in there and do g of t minus g of 2. That will not produce the same thing. That's what I want to show you in these examples here. If we start over here with g of t is 3t minus 4. And then g of 2 is saying take a 2 and place it where that t is, which is going to look like that. There is g of t, 3t minus 4. And then here in red, I've replaced the t with a 2. And I want to make sure I've got parentheses around that because I want to subtract all of whatever g of 2 is. So I want to put a parentheses after that subtraction. Without that parentheses, I would only subtract the 3 minus 2, but I want to subtract the 3 times 2 and the minus 4. I want to subtract all of this stuff, so make sure there's a parentheses there. We can simplify that down a little bit, multiplying the 3 times 2, that gets us 6, and distributing that negative over to the 4 makes it a plus. And then finally, the negative 4 and the positive 4 makes 0, so we just get 3t minus 6. Now over here, we should get something different, and we will, because we can't just like distribute this g over that parentheses. This g of t minus 2 is saying where that t is, we're going to replace it with t minus 2. Just like here, we replace the t with a 2. So it looks like this. We kind of write out g of t, and where that t is, we put that t minus 2. It's not something that gets tacked on to the end. Replace that t with a t minus 2. Then we multiply 3 times t, that's 3t. 3 times 2, that's 6. And then that 6, negative 6 minus 4 gets us negative 10. We can see that these are producing very different things. We also can't like distribute it to the top and the bottom, so these are going to also produce different things. If we wanted to do g of 1/3, we replace that t with a 1/3. So instead of a t, we get a 1/3. 3 times 1/3, that's going to be 1 minus 4. That gets us 3. If we do that separately and doing the g to the 1 and then the g to the 3, we're not going to get the same thing that we got over here. G of 1, we're replacing that t with a 1. And then g of 3 is replacing that t with a 3. Then we simplify the top and the bottom. 3 times 1 is 3. 3 times 3 is 9. Can't quite see it, but then when we subtract those, we get negative 1/5, which is very different from what we got when we did that 1/3 into the parentheses instead of just doing the 1 and 3 as separate things. We cannot just sort of like distribute these function operations. So that's it for our notation. A reminder that f of x is a fancy way of talking about what the output is, what that y value is. If you see any open circles on the graph, remember that we're just approaching that value. We never quite reach it. And I also want you to remember, hey, we can't just sort of like distribute this function operation. That is something that we want to put all of f of x plus h. We want to put all of that x plus h wherever that x value was in the function. We can't just do the x and then the h and then add them together. That won't work. Okay, thanks for watching. Goodbye.